Hello, I'm going to help you run your first quantum program. If you've clicked the link above me or below me, then it will take you to this website. And this website is Google Colab, which is a free resource that allows you to run Jupyter notebooks using everyone has the same environment. So there's no complex installations. So I have a Jupyter notebook that you see here. It's being hosted by Google Colab. Jupyter notebooks themselves are an interactive programming environment to allow you to write text files and do data analysis, write code, share code. A very, very slick way to program in Python. So the language that we're going to be using the human readable language we're using is Python, but that's not the language that quantum computers speak. You often see quantum programs with pictures as like the one you see here. These are quantum circuits, but quantum computers, including the Quokka quantum computing emulator, doesn't speak in pictures. It speaks in code, and that code is QASM, or quantum assembly language. And a QASM file is a text file. It looks something like this. So I type that out by hand in the text editor. In order to actually send something like that to Quokka, I need to create a variable that holds that text string and send it to my Quokka address. So a pictorial representation is I have my quantum program, it gets sent over Wi-Fi to my Quokka, and then the Quokka returns the answer of reading the qubits after executing the program. So the first thing I'm going to do is use Python to write that text file. So I've expanded it out in detail how such a program works, but when I run this code cell, I should see a text file that's identical to the one that I want to run, which is visually depicted with this quantum circuit. So let's run that. It gets printed. Indeed, that's the quantum assembly language file that I want to send to my Quokka. To send it to the Quokka, I'm going to import some additional Python libraries that make it easier to make requests over the internet. You don't need to know what those are. It's just a helpful way to send these requests so I don't have to write my own code to do so. And next I need the name of my Quokka. So my Quokka is called Quokka 1, and you're free to use Quokka 1 so long as I have it plugged in. If you have your own Quokka, it will have its own name that you'll see after you onboard it to your Wi-Fi network, or you might be given the address of a Quokka that's in the cloud. So we need to run that to define the web address of the API that's sitting on my Quokka, waiting for these QASM files to be sent to it. Last but not least, I need to run the next line, and what this does is it wraps the program into a dictionary with two keys. One's called script, that's where the program sits, and count, which is the number of times you want to run that program. Then I make the HTTP request, so that's this data being sent to my Quokka and the results being stored in this variable. And then I just need a little bit of helper functions to pull out the data and print it to the console. So when I ran that, I see that there's no error, error code 0. You can read the documentation with the link below to see what all those error messages might mean. And then the results of reading the qubits are stored in this dictionary key location called result. So in this case, what you see is 10 bits, and they look pretty random. That's because the code up here was to implement a quantum coin toss. So this simple 1 qubit program is a quantum coin, sort of your hello world quantum program. And if we run that again, like flipping a coin, I should see a different strings of ones and zeros. So that got sent to my Quokka 1, and the results 1 0 1 1 1 1 1 0 1 0 0, a nice random string. And then from here you can see some more Python notebooks, and they include one about quantum computing myths, one about how to make a quantum game, and of course you can read the documentation So there you have it. Happy quantum coding.